So yesterday we started the P6, P7 notes on probabilities involving not, or, and then. We reviewed that probability of not an event, you take 1 minus the event happening. We talked about the probability of or, which means we need to add the events, but we need to subtract an overlap if there is any. And then we also talked about the probability of then, which you might also read as an and statement. And that means we multiply the events, but you need to consider if there's replacement or not. Do you need to remove the denominator? So let's go down to 1b, since we did not complete that one yet. Not rolling a number less than 4. So we're going to take the probability of rolling a number greater than or equal to 4. Which that is the opposite of rolling a number less than 4, and we want that to not happen. We could also follow the rule, probability of not less than 4, and then 1 minus that. So there's a couple different ways to look at it, and a few of you asked me yesterday if we can just do the opposite, which is shown here. So it doesn't really quite matter which method you take, as long as you understand that we're doing not less than 4. So the probability of not less than 4 is the same as the probability as a number greater than or equal to 4. If you think of the numbers on a die, 1, 2, 3, 4, 5, 6, greater than or equal to 4 is 4, 5, and 6. That's 3 out of 6, or 1/2. Let's look at it then using the rule 1 minus. So 1 minus not less than 4. So less than 4 would be 1, 2, and 3. So that's going to be 1 minus 3 out of 6, which is 6 out of 6 minus 3 out of 6. We get the same result. Okay, moving down to problem 2. A toy box contains 12 red blocks, 9 blue, and 4 green. Suppose you reach in and choose 3 blocks. Find the probability that no blocks are red. So if we're looking for no blocks are red, I want to think about the probability of the blocks being red. There are 12 red blocks out of a total of 25. So then, probability of not red is 1 minus that. That gives me 13 out of 25. So the probability of not red is 13 out of 25. But then we're doing this 3 times. When it says you reach in and choose 3 blocks, that means we're not putting any back. So the first pool is going to be 13 out of 25. The second time we reach in is going to be 12 out of 24, because we're assuming we got the red block that we wanted and we're leaving it out of the bunch, so our denominator decreases. And then our third pool, again assuming we got another red block, is 11 out of 23. Go ahead and multiply all those together and simplify them on your own. You can hit pause if you need a little bit more time. Your final answer then after you simplify is 143 over 1150. Okay, moving on to number 4. You are dealt a card from a standard deck of 52 cards. I did post a picture of a standard deck of 52 cards on our Schoology page in the probability folder. You'll see a picture there. Find the probability that you're dealt an ace given that you know the card is red. Okay, so this is a given statement. So let's go up to the directions to talk about the given statements. Probability of A given B. This is when one event occurs after narrowing down of the original set of items to a smaller subset. Probability of A given B means we're looking at the probability of B and the probability of A only from subset B. For example, the probability of honors algebra 2, given you're in 9th grade, would mean that you would find the probability of a student taking honors algebra 2, given that they are in 9th grade. So of the 9th grade students, that becomes your population. And of the people in that population, the 9th grade population, we want to know how many of them are taking honors algebra 2. So that's the given statement. So now let's go back to this problem and read it again. From the standard deck of cards, what is the probability of drawing an ace given the card is red? So we can write that as the probability of ace given red. So that means we're going to look at red aces because we're only looking at the population of red cards. And there's my population, red cards. So of the population, red cards, what are we given? We're given the red cards. That's my denominator. How many of those are aces? Okay, so how many red aces are there? There's 2. How many red cards are there? That's half the deck, so that's 26. So our final answer is 1/13. All right, on the next slide of the Nearpod, you'll get some practice problems, so use these notes to help assist you.